We're live. What is this, Lady Ada?
Hey everybody, and welcome to yet another amazing year of show and tell. It's me, Lady Ada. With me is Mr. Lady Ada, and 2018, the year of the maker. We're making it.
We say that every year.
That's true.
Hey, it's working out.
It's working out.
If you keep saying it, it must be true.
Everyone around the world, come by, show off your project, what you're making, your craft, and your coding. We'll be here till 7:50, so take a few moments to show off your project, unmute your mic when we call on you. Otherwise, keep your mic muted and get your demo ready to show off when we call on you. We're going to start off with some Adafruit peeps.
All right, first up.
Now Pedro.
No, Pedro.
Hey guys, we've been doing a lot of time-lapse stuff lately, and it kind of gave me inspiration to upgrade a project we did a couple years ago, which was a motorized camera slider. So I showed this off, 2 weeks ago, or maybe last week. Finally finished it and put a guide up on the learning system. And this is it. Still fits in my hands. I can still pick it around. It's about 500 millimeters long, so it gives you pretty decent travel. And I don't know what else to say about it other than it's fun to use. It does a really good job at capturing build processes and some other fun stuff, like, I don't know, opening up Christmas presents. That was fun. Using it to, of course, do Lego builds and stuff like that. I think it'd be fun to take it to the office and set it up next to the pick and place. That'd be kind of neat. Or like near Kidding.
Yeah, speaking of, the team here did a video doing just that. We'll have it on our manufacturing videos.
Awesome. Cool.
It must have heard you from the past or the future. One of those.
Okay. So if anybody wants to kind of build their own or get like inspirational ideas and stuff, check out the video up on YouTube. And the guide is up and published. So you guys can check that out. Also, the stuff is on Thingiverse as well. And you need to get it up on the other sites too. I forgot to do that. But yeah, we also did the Hangout show this morning, which was a lot of fun. Thank you guys for joining us there. And yeah, that's it from us, really.
Nice work.
Okay.
Thank you.
Another year of printing a bunch of stuff.
Yeah, totally. Yeah, thanks, guys.
All right, next up. Scott, what you got cooking?
What do I have cooking? Nothing yet, because my toaster oven is in pieces. Some of you, I think I mentioned it before, I'm working on redoing the guts, the brains of a toaster oven so I can use it to reflow if I ever get to that point. The guts that I want to replace look like this. The reason they look like this is the front control panel. And so this is the front control panel of a fancy toaster oven. The knob is not there, but this is where the screen goes. And then these are buttons. And it's kind of interesting because the buttons are connected. I guess I could just show the back. They're actually connected, but on flexible plastic. So they come as a chunk. And what I was doing is I'm trying to create a replacement for this board, which has a microcontroller on the back. I wanted to run CircuitPython because I work on CircuitPython and it's awesome, but also because then I'll be able to control the toaster oven from code. So the challenge is making a new PCB design this size that has all the button placements in the right spot and all of the little nubs and stuff in the right spot. So I took Monday off because of the holidays, and I just was printing tons of copies of the circuit board, trying to make sure that my placement of everything was really spot on. I don't expect it to be. I hope at least I can fit it there, and maybe some of the screws won't fit. But it's been a huge, interesting challenge. It's all, in my mind, mechanical engineering, which is fun. I've never done. So yeah, that's not really Adafruit related. 2 notes to go along with that. I use KiCad because KiCad's awesome and open source for all my designs. And they're doing a hack chat on Friday this week about KiCad in 2018. That's at noon. I'll drop a link in both the chats. And then we actually have been talking with them, with the Hackaday folks, about doing a hack chat for CircuitPython. So keep your eye out for that. That's coming shortly as well.
Yep.
Eyes peeled. All
right. Well, thank you, and good luck on Circuit Souffle.
Yeah, thank you. I don't know when I'll actually order the PCB, but Osh Park it will be.
All right. Okay, Colin, Happy New Year. What you up to?
Happy New Year. How you doing? Something simple this week. The internet is all flutter with talk about how big people's buttons are and how
I've
big
heard-
other people's buttons are in comparison.
I've heard you have a button on your desk.
I'm not one to brag, but on my desk right here is a pretty large
Oh
button.
no, you have the biggest button.
Yeah, hey, whoa, I'm not comparing button sizes. I'm not about that. I'm just sharing
All right. Well,
this button. This is actually an enlarged version of a mechanical keyboard button. You can see the mechanism.
You got an LED on it.
I did. It fits a 10 millimeter LED rather well, and you can see, yeah.
oh, nice.
That is nice.
Yeah, so you can do backlighting on your giant important button, which triggers horrible things to happen, or possibly really fabulous things, and that's what I'm gonna do with it.
Isn't there a movie where like Matt Damon gets shrunk down, and then they're all small, so they use up less resources? Maybe you just got shrunk down. Maybe the normal size button.
Perhaps. I'm looking around. The cat does look a little bit bigger.
Okay.
Tonight,
Yeah,
but yeah, we'll have fun.
all right. Well,
More to come. More to
stay
come.
safe and please don't start an international dispute.
Hey, it's a peaceful talk about buttons.
Outstanding. All right. Next, Blitz City. Hello, Blitz City. Welcome back. Happy New Year.
Hey, how's it going? Happy New Year. So I've got just kind of a simple project this week. I've been doing a lot of 3D printing. I actually built a Prusa MK2S kit last week. And I was kind of silly and thought I'd have it built in time for show and tell, but I was definitely still deep in the process when you guys were on the air. But I was able to print a Joelbot, which got kind of some hype in the fall, and I failed like 3 times, but eventually got the details down. I also printed a solder wire holder, so when you're when you're soldering 2 wires together, you can have them kind of stiff in the middle. And then what I designed a solder sponge holder in Fusion 360, and it fits the big ones you guys have in the store. And I made it so that the holes in the bottom are little cats.
Good.
And it's the same filament as the solder holder, so they match nice and pink. So yeah, that's what I've been working on.
Okay, Rad, we'll keep coming back. An excellent Sonic Youth poster in the background.
Yes, yep, thank you.
Oh,
Good
nice.
work.
Classic.
Excellent. Yeah.
More
Okay.
cats.
And yeah, anytime you have the opportunity to print out something that could be cat shaped,
Go for
it'll
it.
always work out. Because then, like the sponge, when it like dries into it and you take it out, it'll, like little dried cats.
Yes.
See, this is the things you have to think about when you're doing this. Okay, next up, Coding Pro. Hello, Coding Pro.
You're getting pro.
Hello. So for Christmas, I received a 3D printer. which I
Wow.
have somewhere.
Not a bandsaw. You got a 3D printer, not the bandsaw. Bandsaw.
So I just got some new filament today, and I printed a little design. I made its little die. But also today, I ran my first Circuit Python program. I actually have
Yay.
and I took a Python program I had written a few, maybe last year or something, and put it into my Gem M0, so I can show that
Go for it.
into so that.
Okay, Coding Pro. If you remember, after the show, email support out and tell them that you're getting a limited edition, as in this is just the ones we have of a Blinka Circuit Python temporary tattoo.
Okay, so
You get this.
in my terminal, I have this connected as my USB modem here. Copy that, I can go, I'm going to open up to it, 1.200, I think, and it lets me into it. Right?
We are in the REPL.
Freezing me. No. Don't do this.
Right,
Do you want to hit Control D to reload it? Is it?
hit Control D.
I'm going to try again. Let's see.
You want us to come back?
Yeah.
Yeah, we'll just come back.
Okay.
All good. Okay, next, Daniel. Hello, Daniel. How's it going?
Good. How are you?
Ooh, yeah. Wall art.
Yes. Yes. So tonight I thought I would show another Circuit Playground project that we did. This is my son Jacob. There he
Hey,
is.
Jacob.
All right.
Hey, Jacob. How's it going?
Jacob really likes the movie Tron, so we want to do a Tron themed one. And so what we did is we have here, I'm going to switch my camera real quick so you can see it better. Oops.
Okay, while you're switching cameras, if you email support at adafruit.com afterwards as well, you'll get, Jacob, you get a Blinka Circuit Python temporary tattoo.
Cool. All right.
Yeah.
So this is, we made a hand scanner, sort of a fake hand scanner out of the Circuit Playground on the back.
Okay.
So we got this little hand scanner. So he's going to be able to scan his hand. And let me turn this back here. He's going to be able to scan his hand. And he's going to be able to sort of go into the computer of Tron.
Yeah.
That's cool.
We have a Circuit Playground, and then we have a wire down here connected to a digital logger I/O device that will then switch on EL wires. So it's using that. So I'm going to turn the lights off, and he's going to scan his hand while I turn the lights off so you can see it better.
Cool.
All right.
Get ready. Oh,
Oh, neat.
you're in.
He's not in yet. He's getting scanned in.
No, he's getting
Okay.
scanned first.
Okay.
I'm putting
Yeah.
you on the game grid, Jacob.
So now he's on the game grid. So now he's inside Tron. So now he can pretend he's inside the computer. So that's his.
Hey, fight for the user, Jacob.
Yes.
Yeah.
So that's his. So that's our little project with the Circuit Playground. It's kind of a fun little project for him.
This is fantastic.
Nice work.
Great job.
Both of you did really well.
All right, you get the special Circuit Python sticker. Email support at adafruit.com. Okay, we'll go back to Coding Pro. You ready?
Yep.
Okay, take it away.
Because I'm small, I don't know, problem just froze. But I'm gonna import my program, which is on the device, and then I can do like I made this a long time ago. Let me see if I can remember. Color dot set. So now, no.
By tabbing, you can tab and it'll tell you what.
Oops. There. So I have bold text and then like
Ooh.
Look at that.
dot set purple. Now I have bold purple text and then color dot mode blank, I think. No, color dot type blank.
Now, for the folks at home that are watching this, why this is so neat, this is on a board, and you're watching live programming through a terminal. This is instant ways to teach computer science.
This is nice.
And
Nice
Coding Pro
work.
is doing a live demo, live over the internet. This is kind of, this is crazy.
I had to update it to the new Python, and then I I think Scott helped me with this on Discord, but it's pretty cool now. So
That is
That's
cool.
cool. Well, thanks for showing that, because it's when we tell people like, oh, you could do real-time programming and it does all this stuff, and then you just did a live demo, so I'll just send them a link to this.
Nice work.
All right, good work, Coding Pro. Okay, next up, Isaac. Hello, Isaac.
Hello. So, can you hear me?
Yeah.
So I wanted to make a simple meditation website, and I wanted to, when I'm doing work, sometimes I get distracted and it's easy to open up another tab. So I made this simple little website, and you can, it's a rain simulation, but you can hit different keys, and it should sound pretty good no matter what you hit. All the intervals are set to intervals that sound nice. So yeah, whenever I get distracted, I kind of just open it up and it calms me down a lot. So I did it on, I used P5.js, which is a JavaScript library that is for like designers and artists, and I was able to learn it pretty quickly. And I used this guy's code. He did Purple Rain in our prints. I just changed some of the colors and added some sounds and some interaction. And so, yeah, if you ever want to calm down, visit my website.
That's
Yeah.
nice.
Email support at adafruit.com will send you an as seen on a show and tell sticker, which is it's a physical sticker, so you can just like look at that. It's not a digital sticker that'll like take you to a social media site with a bunch of likes.
It's
and,
very relaxing.
yeah, that's kind of neat, because by instinct now I just go to multiple tabs. I'm like, why did I just do that? And like that's neat. if my tab always opened up to that web page, it'd be like, oh, chill out time, instead of like aggravate time. All right, well, send a link to the website.
Will do. Thank you.
Thank you so much, Isaac. Okay, next up, JMK. What you got going on, JMK? Yay!
Hey!
So, first I just want to say that the reason I wasn't here last week is because I was actually going on a plane home from Miami.
Yeah.
So, but anyway, after 2 weeks, JMK Watch is pretty done. So anyway, what we've got is we've got a red and yellow watch band. And using the magic art of paper tape, the best prototyping stuff you can use. I made a little program.
Oh wow!
Cool. What's it say? Because we can't read it.
So it just says it pretends you're in JMKOS and just types for you. So like,
cool.
display.print P and then delay 1000, and then it keeps doing that until it finishes potato. And then you click enter, and then it says potato back to you. And then it does that again, and then it does time, and then it does time back to you. But anyway, that's only one of the programs I made in Arduino. So
Potato time.
Yeah.
I love potato.
Potatoes are so good.
Also, the one thing that isn't good, that because I missed Saturday, I was on vacation, is that JMQS 1.8 is being delayed until next Saturday or Sunday. So, well, that'll come out, and then also Circuit Playground.
Oh, nice one. All right, you got tons of stuff to play with.
I was actually working on a YouTube video today on Circuit Playground, and running CircuitPython on it. I was modifying the basic red LED blink program, and then looking at the tutorial, and then yeah. So anyway, yeah, I actually just finished putting the band on today.
Good work.
But anyway, yeah, there it is. And yeah.
All right. Well, email support at adafruit.com. Get a show and tell sticker, and then when you launch JMKOS 1.0, email PT at Adafruit. We'll do a blog post on our site. Because I'll get the scoop before TechCrunch. So
Awesome.
that's the goal. Okay.
Congratulations, you're a hardware and software company.
Yeah.
Well ahead of everybody else.
Yeah.
All right, good
All right,
work, everybody.
Well, Happy New Year. I look forward to all your projects this year, JMK.
Yeah, happy 2018.
Yay.
Happy 2018.
All right. Adam, what you got going on?
Adam?
Can you hear me?
Yeah.
Cool. So, it's not running right now, unfortunately. We'll start out with that. But it was running last night. It was running really well last night. Finally back down at high vacuum. I did a stream last Wednesday or Thursday where I went over trying to fix the stage controls and the stage on this thing because there's a giant vacuum leak on here. That fixed it some of the way, but it wasn't quite the entire problem. It's actually a really ironic failure I had this time. The leak valve was leaking when the leak valve should not be leaking, which is not the failure you want to see, but it was constantly letting atmosphere in, constantly leaking when it shouldn't be leaking. Normally, that valve is what you use to release the vacuum in this when you want to bring the chamber back up to atmosphere so you can actually open it. Like right now, there's no latch on this door, and it's stuck in place just because there's 15 or 14 pounds per square inch pushing this door closed. So you got to have some way of opening this chamber up gently. Once I did that, I was able to successfully take the SEM to high vacuum. I've got a kind of a little bit sketchy. I got a multimeter plugged into these test points down there, and it reads out current, and that tells me how good the vacuum is. But once I did that, I went through, and if you see behind me, there's a bunch of books there. That's actually all documentation for my SEMs. Most of it's for this one. So I was reading through the service logs, and the service logs are great because I have notes from engineers who did this professionally. And one of them just casually pointed out, oh, there's a leak rate check you can do. If you have more than 4 microamps per minute of leak rate, or so your current increases by that much, then you can't run your SEM. I'm at like 4.1 right now. So not quite where I should be. I started the process of diagnosing that. I've isolated, used my cross valves, the top of my column from the bottom of my column. At the bottom of my column has a leak rate of 0.1 microamps per minute. So it's amazing. It's a great vacuum.
Not too bad.
But the top, where the really expensive electron gun is, that's not so much. That's got a really bad leak rate. And that confirms my suspicion. If you look at, this is the filament that was in there that burnt out. You can see it's blue. And normally it should be blue, and there's a little bit brown in it too, but it should be a really light tint. It shouldn't be that dark. And that dark indicates that there's a giant vacuum leak. And while I can make images with it, these are $50 to $60 a piece, and the minimum order quantity of 10. And I do not have enough money to buy any more filaments right now. So I've got like 2 more filaments before I have to either buy more or figure out how to make them. So I've got to be very, very certain I've got my vacuum leak taken care of before I continue on with that. So depending on how things go during Ask an Engineer, I'm going to start doing some basic diagnostics. If it looks like something I can solve tonight for my vacuum leak, I'll go ahead and start a stream up and I'll announce it in the Discord. But if not, I'm going to have to go find other equipment to use to find this vacuum leak. So anyways, it's been an interesting week.
Good stuff. I had one quick question for you because I was talking to Lamore this morning about absolute zero and vacuums, because this is what we talk about off camera, of course. So when you do a vacuum, is there any significant temperature change at all of any of the things that are inside the vacuum?
So what happens in a vacuum is that you lose a major form of thermal transfer. That's conductive heat transfer through the air. You're still left with conductive heat transfer through materials and conductive heat and radiative transfer. So the materials themselves won't change temperature if it's just a block of material sitting in the chamber. However, if the block has moisture on it, or if the block has a heater in it, then it will change temperature. Like if it has a heater on it, the block will get hotter than it was before in atmosphere because there's less air molecules to take the heat away from it. And infrared heat loss isn't nearly as big of a factor as conductive heat loss through the air is.
That makes sense.
And then, like, of course, if something's moist, you'll see some cooling. That's not a big effect. But like, if you want to heat something in vacuum, you either have to be in direct contact with it, or you have to use infrared radiation. So you actually see a lot of vacuum systems that have they look just like old halogen work lamps, like those long bulbs. They'll have those inside your chamber, and you use those to heat your whole vacuum up. When you want to get to like really good vacuum, like 10 to the -9 torr, like deep space vacuum, you actually have to heat everything in your chamber up to get the water vapor off. There's water vapor that binds to the walls of the chamber. Just any metal out there has a little bit of water vapor kind of bound and in the surface of it. So to get rid of that, you actually have to heat that whole thing up. So you'll see those infrared heaters, or you'll see coils strapped to columns or chambers and whatnot. So yeah,
okay. All right.
Heat in a vacuum.
I was thinking about this, and then I'm like, oh, I know who I can ask later.
Yeah. One more quick tangent on that, if we've got time. Yeah, we got a little bit. Is the radiological thermal electric generators, like on spacecraft. It's incredibly, or just spacecraft in general, it's really cold in space, but because there's no atmosphere in space, it's really hard to actually do thermal management. You don't have any air to conduct things away. Heat sinks don't work the same. You can't blow air by a heat sink in space. You have to conduct the heat away from whatever your electronics or whatever, and just get a big enough surface area to radiate it, to radiate it away. So the thermal properties of things in vacuums are definitely a big concern for spacecraft and whatnot. So.
Yeah. All right. Well, thank you so much. That was a perfect answer. All right, C. Scott, play us out. Happy New Year. Welcome back.
Hey guys, hear me?
Yep.
All right. Some Circuit Python. This is the Circuit Playground. See, with a FeatherM0 Express on it. I haven't made the panel yet, but it'll look like this. But this is what I have hooked up right now. It is programmed right now as a MIDI CV with a second control voltage channel to let me open and close the filter. And it looks like the camera will give me, it looks like that. Sorry for the angle. Like I said, I don't have a front panel yet. I have to kind of just set it there on top of my module. That's a single voice Croby X. Anyway, as you can see, I'm decoding MIDI notes. It's matching the channel number I've programmed it. Right now, this is what I call version 1 of Module Playground. I'm going to go on and send it to you guys.
Ooh, Module Playground.
I'm into it.
I'm also going to give you this is the through-hole version. I'll give you the SMP version if you want to make them, you can be my guest. Because it's like, hey, look, something to do with the Circuit Python that can into your music rack.
That will immediately go to Colin, and we'll probably do something with it.
is there's 3 knobs on 3 of the AD channels. There are, let me go back to the picture real quick. So we can get a
Cool. We got circuit souffle. We got module Python.
Yeah. Well, the front panel is going to say featuring the Feather M0 M4 Expressive Circuit Python. So I'm thinking VM4 already, but Python power. But you have a MIDI input, gate status. That's connected to line 13. It'll come on and off with your LED on the back. But it's not the jack at the bottom. You'll see 4 jacks at the bottom. Gate out is not connected to the same line, so you can have the status indicate something other than the gate state. I'm trying to make gate out do double duty because you'll notice in parentheses to the side it says analog in 5 volts. It clamps a 5 volt signal, a maximum of 5 volts. So if you wanted to sample something in and play around with it, you can. You got 2 control voltages out, and then you have an audio out. That comes, you can either use one of the PWM registers or the A0 to send audio information back out and try something. There'll be a little 64 by 128 by 64 OLED, 2 buttons and a switch, all playable or programmable through the CircuitPython. So I'm trying to get, this is a 10 HP, it's a 2-inch wide module. I'm trying to give a lot of bang for the buck for people who just want to not only learn CircuitPython, which has turned out to be really cool. I did not expect it to be able to process MIDI this well, and it has no problems whatsoever.
Yeah.
It's really good for processing strings of binary data, like surprisingly easier than Arduino, because you don't have to manage your buffers.
Right. Well, whoever wrote the buffer management and the serial routine knows what they're doing. I hope in the next build of CircuitPython, not necessarily 2.3, but like 3.0, I would love to be able to have only set it to receive and not waste the transmit pin, because I don't need a full duplex UART. I just need to receive MIDI. And especially if you have like the trinkets and you only have 5 lines, you want to be as versatile as possible. But it's not really a quibble. It's just like thinking ahead. I think it could be done. You just tell them, don't assign that pin to do anything. Do something else.
Totally.
Anyway, that's Circuit Playground, Module Playground, Feather M0, CircuitPython, Magic Python is awesome.
All right. Thank you so much, Scott, and Happy New Year.
Everybody loves Blinka.
Happy New Year, guys.
Okay, thank you, No Pedro. Thank you,
Python,
JMK. Thank you,
Python.
Isaac. Thank you, Daniel. Thank you, C. Scott. Thank you, Colin. Thank you, Coding Pro. Thank you, Lit City. And thank you, Adam. We're here every single week. Thank you for making 2017 bearable and something to look forward to every Wednesday. And hit the ground running, as they say, in 2018. We hope to see all of you all year.
Thanks, everybody.
Ask an Engineer starts in 1 minute.
Bye.
Bye-bye.